Rolle's theorem. Rolle's theorem says that we have a continuous differentiable function where f of a equals f of b. If all of those things happen, then they guarantee you at least one number c on the interval such that the derivative is 0. So this theorem basically will guarantee you a max or a min. But it has conditions, okay? So specifically, the three things that you have to check to make sure that you can apply the theorem, and then we'll go back and talk about this part, is it says that you need a continuous function on the closed interval. So specifically what you're checking, you have to make sure that you have no asymptotes. That's the continuous part, okay? On the interval though, if you're looking from A to B and you have an asymptote out here, no one cares. You just need to look within your interval. You have to make sure that it's differentiable on the open interval. That means no pointy spots. It also means the derivative has no asymptotes. So if you're not sure by looking at the graph if it's pointy or not, then you want to look at the derivative function and see if the derivative would have any asymptotes. Okay? And the third thing is that f of a has to equal f of b, so that means the endpoints match. So here they want to know why Rolle's theorem doesn't work for the graphs. So this one, it's continuous, endpoints match, but you have this pointy spot. The math words for pointy spot is you say that it's not differentiable. Don't write pointy spot. This one is continuous, not doing anything pointy, so it's differentiable, but the endpoints don't match. Okay? So, if any of these don't happen, okay, so you have an asymptote, you have a pointy spot, the endpoints don't match, then you can't apply the theorem, hence the cap. So a number of years ago, I said if you run into one where it doesn't meet the requirements, you say that you can't apply the theorem. And then I had some lazy people that said, well, instead of writing can't apply theorem, can we just abbreviate it and write CAT? And I said, that's fine. And then other people wanted to draw pictures of cats. Also fine, okay? As long as you understand the meaning behind it, I don't care if you write cat, write can't apply theorem, draw beautiful pictures, totally up to you, okay? So we're going to do one problem that sort of illustrates the theorem, and then we're going to do a few where we try to apply the theorem, and then really that'll be it. So first one, they want you to find the two x-intercepts of the function and show that the derivative is 0 at some point in between them. Like it says here, the reason that you want the x-intercepts is so you know the endpoints match, because they both be 0 if you're looking for the intercepts. And they're asking you to practice applying the theorem so you don't have to check to see if it's continuous and differentiable, because they've set that up for you. So first thing you want to do is you want to find your intercepts, which means you're setting your original function equal to 0. So then you've got 2x is 0, so x is 0. Square root of x plus 3 is 0, so really x plus 3 is 0. So then x is negative 3. So your interval goes from negative 3 to 0. So you want to find the derivative and establish that it's 0 somewhere between negative 3 and 0. Since they specifically asked you to find the two x-intercepts, you can write them as points. Wouldn't be a terrible idea. All right, so then you want to find your derivative. It's a product, so you have to do product rule. So you've got first, derivative of second, so then you pull down the 1/2, which would cancel out the 2. plus second derivative of first. And then you want to clean it up. So then you're looking at x over the square root of x plus 3 plus 2 square root of x plus 3. Figure out where it's 0 and establish that that's somewhere between -3 and 0. So I would just make common denominators here real fast. So then you're looking at x plus, if you distribute the 2, because the square root would go away, you've got 2x plus 3, 2, 6 over square root of x plus 3 equals 0. And multiply that over, so that's gone. So then 3x plus 6 is 0. Subtract by x is -2, which is between -3 and 0. So that would establish that you found it. Okay? So the back page actually wants you to try and apply the theorem. And when you're trying to apply the theorem, that's where you have to go through your checks. So if you can apply the theorem, then they want you to find the values you see on the open interval. Notice here, because of the parentheses, it's an open interval, which means if either of your values that you find is an endpoint, you pitch that one such that f prime of c is 0. So also notice that they're calling them c values. So once you found them, you have to call it a c value. You can't leave it x. This one, they didn't call it a c value. You're just establishing the theorem, so it didn't matter. But here, you want to make sure you call them c values. So, like it says here, once you figured out you can apply the theorem, you need to check it for critical points, make sure at least one of them is located within the given interval. You could have 63 of them within the given interval, but at least one. If you don't end up with at least one, you've made it weird and you have to go back and fix it. So, looking at this, first thing you want to do is you want to make sure it's continuous. That would be a polynomial. They don't have any weird asymptotes, so it's continuous. Thinking about its derivative, it would also be a polynomial, which would become the asymptote, so that's okay. Then you want to plug in -2 and 3 and make sure you get the same thing. So if you plug in -2, you get 0. If you plug in 3, you get 0. You don't necessarily have to get 0, you just have to get the same value. The point is that you get the same value, so that's the same thing. So that means you can apply the theorem. So then you want to take the derivative, set it equal to 0, solve it, and find at least one that falls between -2 and 3. So first derivative, you have to do product rule. So you got first derivative of second plus second derivative of first. Now, when it comes to setting this equal to 0, I cheat in the form of laziness to make it as easy as possible. You could totally multiply this whole thing out. That would be fine. However, one thing to notice is that you have an x plus 2 as a repeated factor, so you could actually take it out as the greatest common factor. So then what you would have here, if you distribute, is just 2x minus 6. What you have here is you have plus 1 more x plus 2. And then you can just set both of those equal to 0. Way easier. So then you've got x plus 2. And that's going to be 3x minus 4 equals 0. So then here you have x is -2. There you've got x is 4/3. -2 is an endpoint, so it's not within the open interval, which means I don't want that one. If it had fallen within the interval, I would keep it, but it doesn't, so I don't want it. 4/3 falls between -2 and 3, which means that that is your c value, and you have to make sure that you go through and list it as c. Don't leave it as x, because you got to make sure you're answering the question that they're asking you for. Right? 3 more. All right, so same thing. First thing you want to do is you want to do your checks. So you want to see if it's continuous from -2 to 2. This one has an asymptote at 0, which falls between -2 and 2. So that means it's not continuous from -2 to 2. So you can't apply the theorem. And then you're finished with the problem and you move on. Okay? He's so happy. No calculus for him. Next one. This is an absolute value function. Absolute value functions are pointy functions. They're V-shaped, so they have points. This one has its vertex at 2, which is between 0 and 5. So while it's a continuous function, it's not a differentiable function. So then same thing. You can't apply the theorem. And you move on, okay? Make sure you do the checks first, because if you don't do the checks and you go through and you try to do everything and then find out you messed up, you've wasted a lot of time for no reason, okay? So, last one. Negative sine of x is a squiggly function. It's continuous. Its derivative would be negative cosine of x, squiggly function. No pointy bits. And the derivative has no asymptotes. So it's continuous and differentiable. 0 and 2 pi are at the exact same spot on the unit circle, so even if you happen to not know what sine of 0 and sine of 2 pi are, because they're at the same point, they're the same thing. So then you want to take the derivative, which is going to be negative cosine of x, set it equal to 0, and solve. So divide by the negative. Cosine, remember, is going to be your x value. So cosine is going to be 0 here at pi over 2, and here at 3 pi over 2, both of which fall within your interval. So this one has 2 c values, which you need to make sure you call c, which is fine. Like I said, you can have more than one, but you are guaranteed at least one if you meet the requirements. And then that's it.